Good morning friends. Today I would like to tell about vapor pressure concept. Already we discussed this topic in class 11 states of matter chapter. Vapor pressure. Suppose if you take any closed vessel, take some amount of water in that closed vessel. If you heat that water, initially water molecules undergo evaporation. This process is called vaporization. After some time, those vapor molecules again comes close to liquid because those molecules loses energy. To gain energy, those molecules again comes close to water. That means vapor molecules is again converted into liquid. This process is called condensation. So on heating, vaporization and condensation both takes place. At one stage, rate of evaporation and rate of condensation both are same. Rate of evaporation means the number of molecules undergo evaporation in unit time. Rate of condensation means the number of molecules undergo condensation. That means from vapor state to liquid state in unit time. That is called rate of condensation. At one stage, both the rate of evaporation and condensation both are same. That state is called equilibrium state. At that state, vapor exhibits some pressure. That pressure is called vapor pressure. So the definition is the pressure exerted by the vapor molecules on the liquid surface when liquid and vapor are in equilibrium is called vapor pressure. If temperature increases, vapor pressure also increases. So between vapor pressure and temperature directly proportional. So that is the relation between them. Next, boiling point. We know definition already, boiling point. Actually the definition of boiling point is the temperature at which the liquid is converted into vapor, that is called boiling point. Here one more definition is there, that is in terms of vapor pressure. That is the temperature at which the vapor pressure of the liquid is equal to atmospheric pressure. That is also called one of the definition for boiling point. For example, if you heat the water vapors at 100 degrees temperature, that is called boiling point. That means at 100 degrees temperature, the vapor pressure of the liquid is equal to atmospheric pressure, that is 1 atmospheric pressure. That's why liquid undergoes evaporation. So that is also one of the definition for boiling point. That temperature is considered as boiling temperature. Here one more point. Between boiling point and vapor pressure, inversely proportional is there. I will explain later about this one, how inversely relation is present between boiling point and vapor pressure. Next concept, volatile substance. Volatile substance means easily undergo evaporated substance is called volatile substance. The substance which undergo evaporation easily is called volatile substance. For example, petrol either. If you take petrol, it undergoes evaporation very easily at room temperature. That means its boiling point is very less. Actually room temperature generally we consider as 27 degrees temperature. At room temperature, if you take petrol in hand, immediately that petrol undergo evaporation. That means its boiling point is very less. Its vapor pressure is more, its boiling point is very less. So between vapor pressure and boiling point, inversely proportional is there. That means if any substance having more vapor pressure, it has less boiling point. Next, non-volatile substance. Volatile substance is easily undergo evaporation. Substances are called volatile substance. Non-volatile substance is the substance which does not undergo evaporation easily, is called non-volatile substance. For example, sodium chloride, glucose, sucrose, fructose. These are considered as non-volatile substance. So this is about vapor pressure concept. Next, here two formulas are there. That is, when two volatile liquids are mixed with each other, then in liquid phase some formulas are there, in gaseous phase some formulas are there. When two volatile liquids mixed with each other, for example, I have A and B, two volatile liquids are there. That means two easily undergo evaporation liquids are there. Before mixing A to B, A exhibits some vapor pressure. That is called partial pressure. That is also called partial vapor pressure. That is also called pure vapor pressure of pure substance. If A doesn't mix with B, A exhibits some vapor pressure, that is called vapor pressure of pure component. If A mixed with B, then also A exhibits some pressure, that is called partial pressure. So in liquid phase, formula is Pa equal to P naught A into XA, Pb equal to P naught B into XB. So total pressure equal to Pa plus Pb, where Pa is equal to partial pressure of A and Pb equal to partial pressure of B. That means when A compound mixed with B, then A compound exhibits some pressure, that is called Pa. Here one more points are there, P naught A, P naught B. P naught A means vapor pressure of pure component A. P naught B is equal to vapor pressure of pure component B. That means when A doesn't mix with B, then A exhibits some pressure, that is called vapor pressure of pure component. If a substance mixes with B, then that substance exhibits vapor pressure, that is called vapor pressure or partial pressure. If a substance doesn't mix with another substance, then also that substance exhibits pressure, that pressure is called pure vapor pressure of pure component. That is the difference between partial pressure of A, that is also called vapor pressure of A, and vapor pressure of pure component. Next, in gaseous phase, this is the formula, Ya equal to Pa by total pressure, Yb equal to Pb by total pressure. Ya means mole fraction of A in vapor phase, Yb is equal to mole fraction of B in vapor phase. So that is the difference between liquid phase and gaseous phase. Based on this, one problem is given in NCERT book. This is the problem. In that problem, vapor pressure of two compounds are given, that is chloroform and dichloromethane. Their vapor pressures are given. At this temperature, they are 200 mm Hg and 415 mm Hg. That means vapor pressure of this CHCl3 is 200 mm Hg and vapor pressure of dichloromethane is 415 mm Hg. Next, what we have to find here? We have to find 2 points. That is, calculate the vapor pressure of the solution prepared by mixing 25.5 grams of CHCl3 and 40 grams of CH2Cl2. That means if this much amount of CHCl3 and this much amount of CH2, both are mixed with each other, then we have to find vapor pressure of the solution. That means we have to find total vapor pressure, that means total pressure, that means we have to find Pa plus Pb. That is the first bit. Second bit, mole fractions of each component in vapor phase. That means we have to find mole fraction of CHCl3 and mole fraction of dichloromethane in vapor phase. That means we have to use these formulas. So we have to find total vapor pressure and we have to find mole fractions in vapor phase. So first we have to find total vapor pressure. Total vapor pressure formula, P total equal to Pa plus Pb. That means Pa, already here I told you already, Pa equal to P naught A into XA, Pb equal to P naught B into XB. Substitute these formulas in this equation. So P naught A into XA plus P naught B into XB. That means P naught CHCl3 into XCHCl3 plus P naught CH2Cl2 into XCH2Cl2. P naught CHCl3 already it is given. Here that value is how much? 200 mm. And P naught B, that is also given, that is 415. Here we have to find mole fraction of CHCl3 and mole fraction of CH2Cl2. Mole fraction formula already we discussed. Mole fraction equal to number of moles of one component by number of moles of all components. That means number of moles of CHCl3 by number of moles of CHCl3 plus number of moles of CH2Cl2. That is mole fraction of CHCl3. While in the case of mole fraction of CH2Cl2, number of moles of CH2Cl2 by number of moles of CH2Cl2 plus number of moles of CHCl3. So again, number of moles equal to weight by molecular weight. That means we have to find molecular weight of chloroform and CH2Cl2. Here first I found molecular weight of CH2Cl2. This is 85. Molecular weight of CHCl3 is equal to this much. So by using that we can find number of moles of CH2Cl2 and number of moles of CHCl3. After finding number of moles, we can find total number of moles. Total number of moles is this one. After finding total number of moles, we can find mole fraction of CH2Cl2. This is the formula, number of moles of CH2Cl2 by number of moles of CH2Cl2 plus number of moles of CHCl3. So that's value is this one. Simply already we discussed in mole fraction 1 point. Mole fraction of all components in a given solution is equal to unity. That means mole fraction of solute plus solvent is equal to 1. So already we found mole fraction of CH2Cl2. So then mole fraction of CaCl3 equal to 1 minus mole fraction of CH2Cl2, that equal to 1 minus 0.688, this value, this much. So if you substitute these values in this equation, then we get total pressure. After finding total pressure, we have to find mole fraction of CHCl3 in vapor phase. In vapor phase, we have to find use this formula. Mole fraction of CHCl3 is equal to partial pressure of CHCl3 by total pressure. Already here partial pressure of CH3, that means P0A XA. If you substitute this value here, you can get mole fraction of CHCl3. Here also you can find mole fraction of CH2Cl2 by using this expression. That means mole fraction of CH2 equal to 1 minus mole fraction of CHCl3. Like this, we can get mole fraction of any component in vapor phase. So this is all about vapor pressure and problems on vapor pressure. This is very important concept. Please solve this type of problems once again. Thank you.